yesterday heard about all the move towards low latency computing and computing at the edge of the telco network. And what I'm going to talk about is some platforms that we have developed in my company IDT along with some industry partners to address that emerging use case. Okay, so IDT is a company based out of San Jose, California. We're about 1,800 people, covering a number of technologies ranging from switching, timing. If you're using an Apple iWatch, the wireless charging is from IDT. We're quite diversified. I like to say we do everything that the big processor guys don't do, and we do all the plumbing and infrastructure around there. So we're friendly with everybody because we enable data to be passed and timed and connected in all of these systems that our processor partners are kind of like the famous guys in. So today's presentation, I'll talk about network trends, talk about RapidIO technology, which all of you use today, but many of you don't know you use. I'll talk about edge computing architectures, the OCP edge computing servers and scale out that we would like to contribute moving forward. And we have this open high performance analytics and computing lab that we would potentially like to align with the telecom project here at OCP. So just a visual for you guys to get things going. As we walk around using our 3G and 4G networks worldwide, we're all basically like communicating with the cell phone towers. And moving forward, the things will be communicating actively with the cell phone towers. In this case, the things, the platform that I'm talking about mainly is vehicles communicating metadata back to the base stations. And for that, we need some really low latency analytics at the edge, very diverse workloads, and emerging applications that will be pushed out from the core to the edge to alleviate congestion on the network and also to provide a low latency user experience. So at IDT, we do a bunch of technologies that will make all of that happen, and I'll touch on that in a second. Okay, so how many of you guys know about the ETSI Mobile Edge Computing Group? Okay, so it's not just me. Basically the whole idea is to have an industry collaboration to figure out how to move computing to the edge of the network to enable all of these emerging applications. So in the ETSI group, it was started by the guys whose logos are in the bottom left corner, Huawei, IBM, Nokia, AT&T, Vodafone, and so on. And we feel that there's a place in here to do systems with very low latency interconnect. So moving to what we had in the past was basically a base station connected with this technology that we have called RapidIO, which is a very low latency multiprocessor technology. And then adding to that, many of you know about the CRAN deployments and trials and so on. CRAN is basically a cloud radio access network where you have centralized processing resources, and then you have antennae all over the place. So in an example that I used at the Lindley Data Center conference, because it was a couple of days after the Super Bowl, we were at the Santa Clara Convention Center, which is not far from Levi Stadium, and then you have suburbs in Santa Clara where people live. And at any point in time, the processing workload could be at home in the evening when we're all with our families and so on. The processing workload could be in the offices in Santa Clara when we're at work, or the processing workload could be over at Levi Stadium when there's 50 or 60,000 people at a San Francisco 49ers stadium. So the idea of CRAN is to centralize the computing resource and have all the data flowing over fiber. And actually, our colleagues at Cavium, I don't know if anyone's here, they did a trial, a really cool trial with British Telecom, running CRAN over GFAS. Who knows what GFAS is? Wireline technology that's higher speed of DSL. And what they did was they used GPAS to go from antennas out to a centralized processing pool to do the base station processing. And the idea there, the nice thing there is we can basically add mobile edge computing easily in this case and do not just the lower layers of the wireless processing, the layer 1, 2, 3, but then moving right up to the application layer to layer 7 by having like the co-located servers. A big discussion in the Mobile Edge Computing World Congress was not if mobile edge computing will happen, but how. And when they say how, it's, well, do we put edge computing kind of in the telco central office? Do we put it in the cloud radio access network? Do we put it up on the post? And how do we manage all of that? And how do we distribute the applications? And everyone's trying to figure that out, and that's fine. I think there's a lot of work to be done to figure out how these deployments will happen. And what I'm going to talk about is way down here, you know, these tiny chips that will enable all of that to happen while our friends in the telco industry figure out what that deployment will be. So we, around a decade ago, this technology called RapidIO was created. And the idea was to take the best of PCI at the time and Ethernet, and now PCI Express. So PCI Express has super low latency, and it's got hardware termination, so it's all done in hardware. But you can't scale out multiprocessor systems. So you use PCI Express to Ethernet NICs or PCI Express to InfiniBand NICs to create scale out. And that adds a fair amount of latency. So the RapidIO protocol was created to eliminate that latency bottleneck, have energy efficient on-die footprint, and scale out. So what's interesting is on your way to this conference today, and we're in a good place for me to ask this question, how many of you guys drove by data centers today? Right? We may have, right? But how many of you guys drove by a base station today? Well, you all did, come on, we all drove by a base station. So what's interesting here is we have, moving to my next few slides, the interconnect in the base station is based on this RapidIO technology that connects FPGA, DSP, CPUs, emerging GPU, and storage. And the idea is basically the base station technology needs to support heterogeneous computing, basically CPU with accelerators to do different layers of the wireless protocol. And it has to do this in a very, how many people here work at a carrier? Everything you guys do is energy, like years ago, the data center guys, before they got to hyperscale, didn't have the energy constraints that you guys did. You guys have had very dense computing energy constraints in every form factor, whether it was in a DSLAM, a wireless base station, a telco central office, an RNC, and so on and so forth. So that paradigm is nothing new to the telco world. And the work that we did to connect all the processing nodes in the telco access network for wireless was based on energy efficient low latency computing. This protocol is actually also used in defense and aerospace. So the joke that I say is the pilot of the F-18 for his radar system, he can't have a reset on a blue screen when he's flying at 5Gs. So the protocol actually has built-in reliable transmission, which on the surface isn't that important, but I believe moving forward in the mobile edge computing, when we start running more mission-critical applications, I won't say safety-critical applications, so there's a subtle difference between mission-critical and safety-critical. Safety-critical is if the thing fails, someone's going to die. Mission-critical is if the thing fails, maybe the mission doesn't happen. So I don't foresee a point in time when we'll offload autonomous vehicles with safety-critical features at the edge of the network, at the mobile edge. but there may be mission critical applications running there for fleet management, for for municipal fleets. You know, I come from Canada, so we've got like all these snow removal things going all over the place constantly. We don't shut down like New York City when there's a storm, right? Like there's all these municipal vehicles, and some of you guys might have seen. There's a the name of the mining company is slipping my mind, but basically what they do is in some of their iron ore mines, they actually, you know, those massive dump trucks that are the size of this room. Well, those things, they got them working autonomous. So there's no driver, no nothing, and they're working like 24/7 because now you don't need a driver, right? So you can just be mining like all day and all night. The shovels and all that, they have human operators, but the trucking back and forth and moving that iron ore around and all that, that's all done in an autonomous fashion. And how that fits into what we're talking about is the type of computing platforms we are developing don't necessarily need to be only for the biggest telcos. There are many use cases that are emerging globally that will benefit from the work that the foundation is doing. And we feel that multiprocessor communication with low latency, specifically with workload optimized accelerators, will be key to making some of this happen. And in the CRAN, we're able to connect multiple computing nodes with very low latency to create like a uniform pool of processors that can manage all this traffic together. Okay, so let me go forward really quickly. I have too many builds in here, so I'll just jump through. So the most interesting part of this slide is in the orange box. There is a statement there that we've shipped 110 million ports of 10 to 20 gigabit per second RapidIO technology into mainly into the telco access network. And why that's interesting is if we ship that many ports from our switching silicon, that means they're connected to processors, ASICs, DSPs, FPGAs, and so on. There's probably closing on 100 million sockets in those base station access networks. And co-located with that will come this mobile edge computing. So from IDT, we view mobile edge computing as a very large opportunity, not just for us. We're way down in silicon, but I think for all of you sitting in this room, this is going to be a big emerging application. The RapidIO ecosystem has kind of grown with 2G, 3G, 4G technology, and we're at the forefront of some of the things that are going on in 5G. And to quote one of the carriers at the Mobile Edge Computing Conference, mobile edge computing will become a key tenet of 5G networks because they need to be latency optimized and work with IoT. They inherently need computing at the, like, you would not put computing at the edge of the telco network unless you care about round trip and latency, right? Because why would you spend money putting those of us who are suppliers, we want lots of computing nodes to go at the end of the edge of the network, right? But if you're a carrier, like, why would you waste your money putting computing at the edge of the network unless you can monetize it by the applications that need latency optimization and the ensuing partnerships that would come with from that with those who want their applications at that network edge. Okay, so plug for our company. We just launched our 50 gigabit per second RapidIO switching technology, switching silicon. It sounds like 50 gigabits per second is not that great, but what's interesting is that silicon is 31 by 31, so it's an inch and change. It's about this big. It has 600 gigabit per second of switching bandwidth in it, and it does it in around 12 watts. So it's like super energy efficient, low latency computing. And yesterday we launched a 4.8 terabit per second top of rack switch based on this technology. And I'll talk a bit a bit more about this. But what's interesting there is being able to create scalable top-of-rack switching optimized to the form factor needed for the telco edge network. So I'll skip over the silicon because I talked about that, and just talk about going from the base station. So this, in the bottom right, what you see is kind of like a typical base station topology with the SoC or ASIC, FPGA, and DSP, and then connected to potentially to CRAN. That was like the San Francisco 49ers Levi Stadium example I gave you guys, to an edge computer. And that edge computer, what we're seeing is there will be a big benefit from standard CPUs with workload optimized accelerators, FPGAs and GPUs and so on. If you talk to the guys at NVIDIA, they have visions of how rendering at the edge in the cloud, not deep in the network, but right at the edge, can enable a lot of the gaming applications that would then offload that to the network edge. Let me just do a time check here. Okay, let me get to the crux of the presentation. So the idea is to create scalable computing technologies that can be deployed in fairly modular, small form factor appliances, and they might be 19-inch appliances. In the case of OCP, I believe right now our charter is that things should be in the data center form factor. So we have a solution there, and we have an example up in the open power booth upstairs with our colleagues at IBM. And but that can also be scaled with multiple nodes with top-of-rack switching if you want to put it in the data center. And we connect that with our base switching technology running at 20 to 50 gigabit per second. So this is an interesting project that we ran on mobile edge computing. Actually, it goes back to, it's getting old now. It's FIFA World Cup 2014 finals between Argentina and Germany. What we did was we took the Twitter traffic of the users and through the mobile network, we ran it through our edge computing appliance and analyzed the user sentiments. You know, were they happy? Were they indifferent? So we had to actually go to layer 7 of the packets, right? And bin the sentiments based on what our analytics application. So it was running Hadoop on top of, in this case, an x86 cluster connected with the RapidIO technology, and diving right down to layer 7 of the packet, and based on certain criteria in the analytics, binning that data. And it was really a test for that operator to be able to articulate, okay, we got all this data going through our pipe. Can we, on the fly, understand what type of traffic is there, and is there a way to monetize that based on understanding what traffic is in there? So that was the context of this example. This is a new project we launched with 5G Lab based out of Dresden, Germany. And the scope of that project is basically combining mobile edge computing and autonomous vehicles. So inside the vehicle, there's sensor management and sensor fusion to make sure that, when I'm, watching Netflix in my self-driving car and someone jumps in front of me, that the self-driving car senses that there's an errant pedestrian and my car shouldn't drive over him while I'm watching Netflix. So there's very complex sensor management stuff that goes on in the vehicle. And this interconnect technology that we have has been used for sensor management for over a decade in aviation and military and aerospace. So we got that part going on where we're doing the sensor fusion and doing the real-time management of the data. And then there's another part, which is the mobile edge computing part. And this is where some of the partners who are part of 5G Lab, such as Vodafone and Deutsche Telekom and all that, that's where their interest is in this, is basically being able to take data from vehicles in the field of a base station and be able to do analytics based on all that uploaded data pushed to that base station, and then being able to hand off to the mobile edge computer between base stations. Because I'm speeding on the Autobahn and I'm going at 220K an hour. So, you need a handoff to say Dev's gone to the next base station, and now you're uploading his data to the application there. And the idea of this project is to actually use the mobile edge computing technology to communicate with these vehicles. And it's, it's 5G research, but again, it's based on the computing technology that we're talking about. So we launched this mobile edge computing appliance at the MEC World Congress in London, UK last year. And we would like to submit it into the OCP TELCO group. It uses heterogeneous computing. You can plug and play with the type of sockets you want to have running in this thing, depending on what your workload is. And as I mentioned, we launched a 4.8 terabit per second top-of-rack switch, also based on this computing technology. And interesting, I said just earlier that the switch we launched is 600 gigabit per second. So in the top left corner, sorry, top right corner for you guys, no, it is top left corner for you guys, my top left, right? You'll see there's multiple switching silicon on there. So we're able to actually create a mesh network that gives you 100 to 200 nanosecond latency. 100 to 300 nanoseconds, depending on how many switches you need to hop through. But in the top left corner, that's 200 watt of switching with distributed, it's distributed power management, and it's a very attractive way of connecting all of this stuff. And we've actually it's running in certain Open Labs data center. And it's also running in a tier 1 cloud radio access network. And we would, our intent is to enable the OCP TELCO project and provide this as a submission going forward as we work with Craig and the crew on the charter. Finally, we launched last year our Open High Performance Analytics and Computing Lab. And the idea there is to basically work with our partners, our silicon partners, our board level partners, and with operators and end users to run test applications on the hardware that we have. So the idea there is before someone decides that they want to go out and get all this OCP hardware, hey, we'll commission a project with you guys over at IDT. And we'll put some of our engineers and software guys and apps guys, and you guys put some of your guys in, and we'll test some of this, not just test the hardware, but we'll actually run applications. So before we launched the lab, that example with Orange Telecom, that's an example of things we've done. We've done some stuff on supercomputing at the edge, the work we're doing with CERN and 5G Lab. And I'll talk about the CERN thing in my HPC presentation that I should be starting in a couple of minutes. So I'll put on my green jacket for that because I'm the co-chair of the OCP HPC. Really the idea was to set up a lab where we can accelerate the adoption of some of this technology, and our customers don't have to buy all the hardware and build everything off the ground before they try to roll it out in their own data center. And from our company side, we are interested in potentially bringing this lab into the OCP fold under the TELCO umbrella and collaborating with the community to enable the accelerated adoption of the OCP stuff. So I'm going to end this presentation. I got a couple of minutes to take questions. If there's a transition of people coming in for my next presentation, we'll let them come in, and I'll start the next one on the HPC stuff. Any questions? How many of you intend to participate in the OCP TELCO over here, just out of curiosity? So we have a good critical mass of people who are going to be involved in the OCP TELCO. So that's awesome to see. Okay, thanks a lot. I'll take a a minute or two to flip presentations, and then we'll get the next one going. Put on my green jacket.
So are you in this room?
Yeah. I believe we're in this room to simplify things.
Okay.
I think our next one is at
12:30.
12:30.
Yeah, 12:30.
Yeah.
Okay.
I've done most of those.
Oh.
Sam Fuller? Oh, I